Hello dear students, today we will start our discussion on the digital electronics, which is the CC7 paper in your syllabus of third semester. As you know, you have come across in your higher secondary classes about some preliminary levels of digital electronics. There you have learned about the digitization of the signal, that is what do you actually mean by a digital signal. In this class you will learn about the clear distinction about the digital and the analog signals, that what is an analog signal and what is a digital signal and how does digital signal helps us over the analog signal. We will also come across the term binary. What is that? That is what do you mean by a binary number. In your higher secondary classes you have converted from your usual decimal number system to the binary number system. Today in this class I will not go into the details of those will be also dealt in our upcoming classes, but you have some preliminary ideas of these effects, so we can safely skip those parts for the first class of today's. We will learn about the positive and negative logics, that what do you mean by logic, because you know that this word has some key role to play. You have come across the logic circuit, the logic table or the truth table, so it's very important to understand the logic in digital electronics. So there are two types of logics, that is the positive and the negative. We will definitely come across this. We will try to learn about the symmetric and asymmetric signals. We will also try to learn about the switching times in this particular class. And finally, we will also try to have some ideas about the different logics. What are the different logics? You have come across the AND gate. So AND gate, although we call it an AND gate, but it is actually a logic, and it is better to call it AND logic, or it is better to call OR logic. So we will try to learn about those. We will also try to understand that why it is called AND, that why the naming, why the nomenclature is like that, and also sometimes it is OR. এই নামকরণের কারণগুলি কি? So we will try to understand all the very basics in this particular introductory class, and slowly we will move on to the in-depth studies of different topics in digital electronics. First of all, I will like to make you understand that you put it in your mind that this is one of the easiest topics in your third semester courses. You have come across the many difficult analysis, like you have come across in your mathematical physics classes, that is the Fourier analysis. You have next come across the method of separation of variables. But digital electronics, you believe me that it is very simple in comparison to the other topics that you have come across. Now the first task is to get the ideas of different books that you can study. The foremost book that you can read is the book by Malvino and Leach. You just go through your syllabus, there you will find this name, Malvino and Leach. So this is a worldwide famous book. So it is taught throughout the globe, people follow this book, so you can also safely go through it. This will definitely help you to understand the basics of it. Most probably you will not find this book in the offline store, so just go for an online buy if you want to read books. So this is one of the finest books in digital electronics. Other than this, some books that will definitely help you at the time of examination. Those books are by Basudev Ghosh, one of the books that is available very easily. You may also go through another book by Eschamp, that is Borun Rai Chaudhuri. So please write the names of these books, but at the very topmost I will keep the book that is by Malvino and Leach, the finest discussion on these particular topics. There are many topics in that book which will not be necessary for you right now, but I think that those will definitely help the person or the candidate who is opting for post-graduation studies. So it's better to have a book by the said author, and you can also go through the other reference books that I have mentioned already. So now here we start. First of all, I would like to mention about the analog signal. So what is the analog signal and what is its difference with a digital signal? So analog signal. Analog signal means the current and voltages we come across in our daily encounter. That is, analog voltage means, suppose I write analog voltage is equals to 0 to 5 volt. This means that all possible values between 0 to 5 are possible. All possible values. Right. So all possible values are possible from 0 to 5. That is 0.1, 0.11, 0.121. All values are possible. And if somebody asks you to plot all these values, so whatever you will get over here is something like this. That is, all possible values are there for any digital signal. You see that all possible values are available over here. Suppose this one is my voltage and this one is, suppose it's the time. Suppose the voltage is increasing with time and you can find all possible values at all possible times. So this is what do you mean by an analog voltage. Whereas if you try to discuss the digital voltage, so what is a digital signal? A digital signal, that means in digital we have only two possibilities, right? In digital we have only two possibilities. One of the possibilities is high and another possibility is low. So high and low are the only possibilities in this digital counterpart of signals. Let me write it in a better way. So whenever I call high or low in digital electronics, whenever I call high or low, you should write it in block letters, high and low. যখনই হাই অথবা লো বলবো ব্লক লেটারসে লিখতে হবে। You have to write it in block letters. High and low, you should always write it in block letters for better understanding, right? So in digital, only two forms of the signal are possible. One is the high and another is the low. Otherwise, there is no other possibility. So high is generally, it is written as 1, this what you have come across already, and low we generally denote by 0, and this one is called the, I was speaking of two types of logic, this one is called the positive logic. So in positive logic, high means 1 and low means 0, and if high is 0, which I am not going to use in my discussion, I am never going to use this one, so this one is called the negative logic. So whatever it's my discussion, so my discussion will be always based on this positive logic, if unless otherwise mentioned. If I do not mention anything, so then I am always discussing on the positive logic, that is 1 is high and 0 is low. So this is what do I mean by digital signal. So if it is a digital signal, then you may have a value at this point, and then you have a value at this point, then over here like this. Okay, so this is what is a digital signal, means the points are not continuous. This means that you have a point over here, you have a point over here, you have a point here, and you have a point over here, and you need to join these all points to get a signal. So that is what is a digital signal. So I explain once again that analog signal means you have all possible values, but digital signal means you have only some particular values are possible, and if you join all these particular values, then you can get the analog signal from here. So now how is the digital signal better to us? It is better in the way that in the digital form you have only two possibilities, that is either 0 or 1. So this is what is the digitization of any signal. Now it should come to our mind that this type of algebra, the algebra of this digitization is called the Boolean algebra. Now this Boolean algebra was developed by George Boole. It is after the name of the mathematician George Boole, Boolean algebra. According to Boole sometimes has said this. So whatever I am going to say next is the statement by George Boole. He said that if human beings had only one finger, মানুষের যদি শুধু একটাই আঙুল থাকতো, if human beings have only one finger instead of those 5, then people would have developed Boolean algebra or the binary algebra at a earlier period rather than the analog or the decimal counterpart of the algebra. So you need to understand this. So actually we have come across which types of algebra first. So from your very beginning days, even at the very development of the human culture, people has come across 0, 1, 2, 3 like this up to 10 digits, that is 0 to 9. মানুষ এইগুলো আগে শিখেছিল. People has learned about this because you can count all those number by the help of your fingers, 1, 2, 3. মানুষের আঙুল দিয়ে এগুলো কাউন্ট করা সম্ভব. People can count all those 1, 2, 3, 4, 5, 6 the way you used to count generally during your very childhood days, যেভাবে হাতে গুনে কাউন্ট করতে, in your very childhood days, we used to count one after another, 1, 2, 3, 4, with the help of our thumb and the different fingers that is associated to us. So that is why, since human beings have 5 fingers, so people can easily count 0 to 20 by its one hand only. And if you use the another hand, then you can count more 20, that is up to 40 you can easily count. And if you use 1 by 1 finger, that is if you raise one finger, it is 1. Jodi ekta angul tolo, eta hobe 1, it is 1. If you raise 2 fingers, then it is 2. This is another way of counting. And in this way, if you raise all the fingers of your hand, of one hand, then it gives you 5. And if you raise both the hands completely, it gives you 10. That is how people can easily count from 0 to 10 or 0 to 9 easily with the help of their fingers. Either by raising the fingers, that is, it will give you 1 to 10, or by simply counting with the help of fingers, that will give 0 to 20 in one hand, and then more 20, that is up to 40 with the help of other hand. So this is what we actually used to do from our childhood days until we come across the digital signals or the binary algebra. So যতদিন না binary algebra শিখেছিলাম ততদিন আমরা এভাবেই count করতাম. We used to count in this method until and unless you came across the binary algebra in your higher secondary classes. So basically we call it Boolean algebra, as it was developed by famous mathematician George Boole in the 19th century. Now according to Boole, if the human beings had one finger, মানুষের যদি একটাই আঙ্গুল থাকতো তাহলে মানুষ নাকি আগে বুলিয়ান অ্যালজেব্রা শিখতো. The statement is simply that if people have one finger only, then human beings would have learned Boolean algebra first during their childhood, because you see that you have only one finger, একটাই খালি আঙ্গুল আছে, you have only one finger. So what will you do if the finger is not raised? আঙুলটা যদি না তুলো, শুধু যদি গুটিয়ে রাখো আঙুলটা, if you don't raise your finger, then it is 0. And if you raise your finger, আমি যদি আঙুলটা তুলি, if I raise my finger, only one finger, then it is 1. So that means that human beings can express only 0 by not raising the finger and 1 by raising the finger. So that is how people would have learned Boolean algebra first in their childhood rather than the decimal algebra or the 0 to 9 types of counting. So the first advantage of this binary, what do you mean by binary? A binary শব্দটার অর্থ কি? What is the meaning of this term binary? Binary means 2, that is only 2 possibilities are there. Binary means only 2 possibilities, and you know by the time that what do I mean by 2 possibilities. The 2 possibilities means one is 0 and the another possibility is 1. So these are the 2 possibilities that we are speaking of at this particular instant. That binary number means there is only 2 possibility for that number, that is 0 and 1. And this is how it is better than the decimal numbers, where you have to write it by combination of different numbers from 0 to 9, but here you can combine only 0 and 1. Now how the binary counting is developed? I think that you definitely know that how to convert a decimal number into binary number. I think you are very fond of those converting, that how to convert decimal into binary. But you should know that why you used to convert it, or how the binary counting gradually develops. Decimale যেরকম একটার পর একটা আসে, in the decimal system you see 0, after that 1, then it is 2, then it is 3, then it is 4, then it is 5, like that. So in the binary form also there is a particular technique or there is a particular strategy that the binary number follows to increase it by 1 units. So here I will show you at least a few numbers that how the counting goes on, but in this class I am not going into the conversions. So suppose this side I write it to be decimal numbers. I will show you first 16 numbers decimal, and this side suppose I write it to be binary, right? It is binary. So what actually happens over here is, suppose my decimal number, the first one is 0. So if I write over here 0, the binary is also 0. So that is, there is no value. Then I write over here 1, that is I increase my 0 by 1 unit. একবার বাড়ালাম, I increase it by 1. So here also you get a 1 over here, right? That's very clear to us. Now I increase this, because 0 means there is no signal, which is 0, 1 means there is a signal, so I write it 1. Now if I write 2 over here, that is I increase my decimal number by 1 units, So you should also increase here also by 1 unit. So now what will be that combination? So that combination is definitely 1 0, because 0 then 1, then what is the higher number? 0 or 1 এর পরে কি নাম্বার তুমি কনস্ট্রাক্ট করতে পারবে? After 0 and 1, which higher number can you construct by using these two numbers only? These two combination means using 0 and 1. So this is how the counting goes on. Next, it is my 3, and here also I need to increase by 1 unit. So what is the only option? The only option over here is double 1, right? Because after 10, this combination, the only combination of zeros and 1 is this one, that is double 1. Then if I would go for 4, you all should remember that the equivalent of 4 is 100, and you see that after double 1, the next combination is definitely double 10. In between double 1 and double 10, there is it is 100. So in between double 1 and 100, there is no other combination. এই যে এটাকে যদি তুমি 11 ভাবো, if you think it to be 11 and if you think it to be 100, so there is no other combination in between these two. There is no other combination in between these two. এদের মাঝখানে আর কোনো combination নেই. There is no other combination that can help you to write it by the combination of this 1 and this 0. And so on. If you move on, you will see that this is 5. For 5 it is 101. For 6 it is 110, and for 7 it is 111. A few factors that you should remember, that you see that the largest 2-bit number, what is the largest 2-bit number? The largest 2-bit number is 11. These are called bits, okay? This one is called bit, this one is called the this one is called one of the bit, and this one is called the another bit. The leftmost bit is called the most significant bit. It is called the MSB, most significant bit, and the right one, the rightmost, is called the LSB, that is the least significant bits. Here also you see, if you go for, okay, so this is the largest 2-bit number, the decimal equivalent is 3. The largest 3-bit number, the decimal equivalent is 7, and here you see the largest 3-bit. 3-bit এর সবথেকে বড় নাম্বার হচ্ছে এটা, that is 111. So here this one is the MSB, that is the most significant bit, মানে whose value is the highest, and this is the least significant bit, that is another one is there. So this is one of the, that is the MSB, and that is the LSB. So these are the two bits that we have been discussing over here. So I hope that you have definitely understood about all this. Now if you similarly move on in this particular fashion, so suppose you start to move on over here like this, dot 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 dot, you are moving, and if you come across this number, that is 15, so if you come across this 15, then you will see that here it will be 1111. So there are 4 ones over here, and this is the largest 4-bit, this is the largest 4-bit number that you come across. So this is the MSB, and this is the LSB. MSB and LSB can be found for all numbers, okay? If you consider this one, so then this is the MSB and this is the LSB. So MSB and LSB can be found for all numbers. Now the question is the highest n-bit number, how to find the highest n-bit number. So let me write it over here, I will write it here for you. Highest n-bit number. I should write something else. Decimal equivalent. Decimal equivalent. Decimal equivalent of highest n-bit number. The formula to get it is 2 to the power n minus 1. So you see that this one is the 2-bit number, so this is the highest 2-bit number because there are 2 bits. So 2 square is 4 minus 1, that is 3, you get over here, and then highest 3-bit number, that is 2 cube. 2 cube is 8, 8 minus 1 is 7, you get it over there, and highest 4-bit number, that is 2 to the power 4. 2 to the power 4 is 16 minus 1, that is you get 15 over here. So I think that by this way you now come across, or you can easily find out the highest, the decimal equivalent of the highest n-bit number. The general formula is 2 to the power n minus 1. So this formula will play a very important role in your different discussions that I will be doing in these classes of digital electronics. So this will definitely help you. Right. So next I come across another topic. So this is how the counting goes on, and how do you convert? I think that you easily know that how to convert from decimal to binary numbers, that you can do yourself. I am not going into the details of it. Now you see that suppose there is an electronic device, and I suddenly change the signal from high to low or from low to high. Try to understand. Suppose there is this one is called the switching time. So next I am going to discuss about switching time. So what is a switching time in an electronic circuit? Switching time bolte ki bujhabo amra. So what is the switching time? Okay, so I will be explaining this. Suppose this is your, in this paper you will come across this one. This is called a block diagram. This is called a block diagram of any particular circuit. So block diagram. Suppose this is your input, this is the input signal, and this one is your output signal. So there is an input signal and there is an output signal. Now ideally what should happen is that suppose this is a type of circuit, that you put a input signal 0 over here, the output should also show you 0. And suppose you put a 1 over here, the output also show 1 at this particular level, right? So I hope that you understand that if you put a input signal, it will show you some input, and it will you put some signal over here, that is 0, you get 0 over here, you put a 1 over here, and you get a 1 over here. Now the question is that does this transition from 0 to 1 occurs immediately? এই যে ট্রানজিশনটা যেটা হচ্ছে 0 থেকে 1, that I put a 0 over here, you get a 0, and I put a 1 over here, you get a 1 over here. So is this transition from the input to output occurs instantaneously? So let me frame the question over here. Is the transition from 0 to 1 or 1 to 0 is instantaneous? Now the answer to this question, that is the transition instantaneous? The answer is ideally প্রকৃতপক্ষে ideally it should be instantaneous. Okay. So as soon as you put the signal at the input, you should get the requisite change, you should get the change at the output. I repeat, as soon as you put an input, you should get an output instantaneously at that particular instant. That is the ideal situation. But in reality, you will see that it takes some time. Maybe it is of the order of nanosecond, maybe it is of the order of picosecond, that is very, very small, 10 to the power minus 12 second, but yet there is a delay in the signal to transit from high to low or from low to high, and this delay is known as the transition time. Now to all the electronics engineer, it is a challenge to reduce this delay as much as possible. First of all, you put it in mind that how much best you try, you cannot make this transition delay to be 0, but you can make it to be as less as possible by different circuitry arrangements, and that is one of the challenge to the engineers, to make this delay as less as possible. But at the same time, if you try to make this delay 0, there arises some other difficulties in the circuit. So there is an optimization. So the engineers have to optimize the different situation that my circuit shouldn't get disturbed, the operation shouldn't get disturbed, but however this transition delay should be reduced as much as possible. Okay, that is some different discussion. We will deal it in some other topics where this has been incorporated in the syllabus, and we will discuss these topics at those particular during those particular classes. But in this class I just want to give you an overview, means this class is not dedicated to understand those delays or to remove those delays. ডিলেটা কেন হয় বা কিভাবে রিমুভ করব সেটার জন্য এই ক্লাসটা নয়. This class is just to give you an idea about what is the transition delay, because you should try to understand it and how can we measure this transition delay. So let me show you a very simple plot over here. So I have definitely collected the plot from the textbooks that I have already mentioned you. So you may go through the textbooks and try to understand it better. I will just give you an overview of this one. You can also get numerical examples from here at the time of exam. Suppose I draw my axial system. This is my axial system. This way I plot the time, and this way I plot the voltage. This is my voltage. Suppose it is like this. Okay. So this is something that I have plotted. So this is the voltage versus time plot for a particular circuit. Suppose this is the voltage versus time plot. Now you see that this is the point where the signal is high. Suppose this is my high signal, and this one we suppose that this is the point where the signal is low. So this is the level where the signal is low, right? So the high point and the low point I have denoted. This is the point where the signal is low. Now whatever I will do is that the definition is something like this, that we have to find the position of 0.9 times of h, that is 90% of h. So if this one is h, so obviously the 0.9 of h will lie somewhere over here. So this is the position. I should be straight enough. Okay. So this is the position of 0.9 times of h. Suppose this is the position of 0.9 capital H, and for L I need to find the position. Okay, I should also drop down the vertical line over here. Yes, and I drop down a vertical line over here also. And then I need to find the position of 1.1 times of capital L. So 1.1 times of capital L means it is greater than capital L. Capital L থেকে বড় হতে হবে 1.1 times. That is, I increase capital L by 10%. Try to understand. I decrease H by 10% and I increase L by 10%. This is the position of 1.8 capital L. This is a universally accepted definition. Now here also I drop the perpendicular. Right. So this is what I have done so far. So what did I do? I have found out the position of this capital H. I have found out the position of this capital H, and I have found out the position of the capital L, that is the high voltage and the low voltage. These two positions I have first of all found out, and then I have pointed out the position of 0.9 times of capital H and the position of 1.1 times of capital L. So this is what I have done so far in this particular case. Now you see that ideally how should the plot look like? So if it is the ideal signal, the plot should be like this, that is this, and then it should go like this. You remember your Fourier analysis classes. So the signal should be this. There should be no time delay, that is, it should be discontinuous, right? You see that there is a discontinuity over here. Just this one is a discontinuity basically. So this point is a discontinuity over here, right? That is, from this point to this point the signal is high, and then suddenly it becomes low at this particular time. And what is the time delay between this high point to this low point? বলো এখান থেকে এখানে time delayটা কত হয়েছে? So basically there is no time delay from this high to low over here, right? So So basically there is no time delay from this high to this particular low. The time delay is 0. So this is what is the ideal situation that I have been speaking of. But in real cases, you see the signal is not that discontinuous, but it is something like this. Okay, it is something like this. So you see that there are some values in between. There are some values in between the high and the low, and this is a practical situation. The upper one that I have drawn is the ideal situation, and whatever I have drawn in the lower panel is this the practical situation. Okay, so this is the practical situation. This you find over here, that the signal doesn't instantaneously drops from high to low, but it takes some time to drop. And how much is this time? The definition is you should measure the switching time. You should measure the switching time between 0.9H and 1.1 L. Now it may come to your mind that why do I measure between 0.9H and 1.1 L? The reason is that the high value, you see, it continues for a finite time, right? And the low values, it also continues for a finite time. Now the condition, it's very difficult to find this sharp edge. It is very difficult to find the sharp edge where the high value has started to fall, or it is very difficult to find the edge where the L value has started to increase. এই এজটা বের করা খুব কঠিন। অ্যাকচুয়ালি ট্রানজিশন টাইম মানে কি, যখন হাই থেকে লো হতে যে টাইমটা নিয়েছে, দ্য টাইম টেকেন ফর দ্য সিগন্যাল টু বিকাম হাই টু লো, that is over here. Here you drop the perpendicular and here you drop the perpendicular. This time interval is called the switching time. The time interval that is taken between this high signal to this low signal. A high থেকে low হতে যে টাইমটা লেগেছে, the time taken by the signal to drop from the high value to this particular low value, that should be the ideally that should be the switching time. But it is very difficult to find this sharp edge, and you may make a mistake that instead of finding this edge, you may slightly get shifted to the left, or you may slightly get shifted to the right by mistaken, because there also the value may be that high value only, because eta jodi line ta hoy, this is the line, so instead of dropping the perpendicular exactly from the edge, you may sometimes get shifted over here, because the value at this particular point is also h, and the value at this particular point is also h. So sometimes we may get distracted from the actual value. So that is why what people have suggested is, instead of taking this h, you measure at 0.9h, because 0.9h is the value that can be obtained at only one time interval. 0.9 টা তুমি অনেকগুলো টাইমে পাবে না। You see that this h you can get throughout this time interval. এই গোটা টাইম জুড়ে কিন্তু তুমি h পাবে। Throughout the entire this time you get the value to be capital H. But this value 0.9h you get only at a particular point, and similarly this 1.1L also. So that is how I allow a plus minus 10%, I allow a plus minus 10% gap over here, and this interval is now defined as the switching time, or this one is called the falling time. So TF is called the falling time. That is the time required for the signal, the time required by the signal to fall from the high value to the low value. High value means not the exact high value, but I take it to be 0.9 and then 1.1. If it is the ideal circuit, so then definitely that time will be 0, because this one is the ideal case over here. So if this is your h, so then what will be 0.9h? Something over here you drop a perpendicular, so this is 0.9h, and if this one is your L value, so this value will be 1.1L, this value, এইটা হবে 1.1L, and what is the time interval between this point and this point? So they fall under the same vertical line. As they fall under the same vertical line, so definitely the time interval over here is 0. So this is the ideal case, and this is the practical case, that if you drop the perpendicular, there is a finite time gap, and this is known as the falling time. And similarly, যখন সিগন্যালটা আবার বড় হচ্ছে, when the signal rises from the low value to the high value, so this one is called the TR, that is the raising time. So people call it raising time. TR is called the raising time. And in most of the circuit, the falling time and the raising time are equal, unless otherwise there is some different circuit arrangement. Circuit arrangement যদি জটিল কিছু না থাকে, if the circuit is not too complicated, then the falling time and the raising time may be same or different. That is different discussion. ওইগুলো আলাদা discussion, that which circuit you have falling time and raising time to be same, in which circuit the falling time and raising time are different. So those are different discussions, and those will be dealt with in some other classes. but these classes is devoted to some preliminary ideas about the switching time. So we understand that in a ideal circuit the switching time should be 0, but in practical circuits the switching time is non-zero, and I have shown you that how to measure this switching time. So it has been clear to you that how to measure this particular switching time, and it is a challenge to the electronics engineer to make this switching time as much less as possible. But if you want to make the switching time lesser and lesser, there will be some other difficulties that will rise in the circuit. So an engineer has to take care of that optimization, that up to how much level you can reduce your switching time, but those are completely different issues, and those may be discussed in your some later classes, but not particularly in this class. So hopefully you have got about the ideas up to here, and now I will show you another issue, that is called the symmetric and the asymmetric signal, and also you will get an idea about the term duty cycle of a signal. So duty cycle is very important. You will see in your practical syllabus that in a few circuits you need to find the duty cycle. देखो practical syllabus बोला, in your practical syllabus I don't know that how much you will be able to do all this in signal. So symmetric signal is very simple. Okay, so this one is a symmetric signal. Okay, so this is a symmetric signal, that is, this is 0, this is t by 2, this is again t, right? So this is again 3t by 2, this is again 2t, and so on. So this is what is a symmetric signal. This high value occurs for a time of t by 2, and again the low value also occurs for a time of t by 2. Low value means this one. So here the signal is low. So it is a high and then it is a low. It is square wave. It is a square wave. So it is a high, then it is a low, and again the high value occurs for a period of t by 2, and then the low value occurs for a period of t by 2. So this is what I am trying to mention, that the high and low values, they are for the equal time interval. So you see that the high signal, the high voltage or the high value is for a time period of t by 2, and the low is also for a time of t by 2. And what is this capital T? Capital T is the time period of the entire signal. So it is the time period. I hope that you have got it. So this type of signals are called the symmetric signals, where the time period of the high, the time for which the high value exists and the time for which the low value exists are equal. So that is called the symmetric signal. Time for the high value and time for the low value are equal. So this type of condition is known as the symmetric signal. Okay, and the duty cycle, how do you define duty cycle? So duty cycle, if I want to find the duty cycle of H, so the duty cycle of H is defined as this one: time of occurrence of H divided by time period of signal divided by time period of signal multiplied to 100. So this is the duty cycle percent. So this is how you define the duty cycle. So in this case you see the time period of occurrence of H is t by 2, the total time is capital T, and this one is multiplied by 100, so this is nothing but 50%. So this is what is the symmetric cycle. The duty cycle of capital H is 50%, and if you go in the similar way, so then you will find that the duty cycle of capital L, that one will be also equal to 50%. So this is how I come to show you that the duty cycle of H is 50% and the duty cycle of L is also 50%. So and this is how you understand that what do I mean by a duty cycle. Now let us come to the asymmetric signal. So what is an asymmetric signal now? So what is an asymmetric signal? So I think that by the time you have guessed about the asymmetric signal and its property. So what is an asymmetric signal? So let us try to show you an asymmetric signal. Please bear with me, it may not be exact because it's very difficult to draw in this digital form, but I am trying to do it in a best possible way. So this side you have the voltage, that is Vt, just a similar case, but now you see that this is the entire time period. Over here you may see, okay, so this is your 0 and this is the entire time period capital T, and this is again the entire time period twice of capital T. So you see that here this is the time interval for which the signal remains high, right? So this is the time interval for which the signal remains high, and the time interval for which the signal remains low is how much? So this time interval is the time of the low value of the signal, that is TL. So this is the low value of the signal, and this one, so this is the interval for which the signal remains high, so this is TH. So let me show it once again for the another cycle. This is TH and this is TL. So you definitely find that over here TH and TL are unequal, right? You have understood that TH and TL are unequal. So what is my TH? TH is the time of occurrence of H. H means high. Time of occurrence of H. At the time of exam you mentioned that what is H? H means high, and TL equals to time of occurrence of capital L, and you see that TH and TL are unequal. So definitely TH and TL are unequal, and this type of signal are called asymmetric signal. Asymmetric মানে কোনো symmetry বা কোনো সামঞ্জস্য নেই। So যেখানে সামঞ্জস্য নেই, where there is no parity between the two signal, I will call it asymmetric signal. So this is how I define asymmetric signal. Okay. So this is symmetric and asymmetric. I made a mistake over here. Sorry. Mistake is just a literal mistake. I have made a mistake in the spelling of this asymmetric, symmetric and asymmetric. Right. So please excuse me. So asymmetric signal, right? So TH and TL are unequal, and then I call it an asymmetric signal. And in my case you see the example that I have considered. So over here you see that what is the case here? Actually TH is less than TL. You may have the complementary case also where TH is greater than TL. And here you see that the duty cycle is not same. The duty cycle is different for the high value and for the low value of the signal, and in this case the duty cycle is a very important way to define. So duty cycle is very important. Duty cycle is very important in these cases. In these cases means the cases of asymmetric signal. Here the duty cycle it plays a very important role over here, because in symmetric signals you see the duty cycle will always be 50%. 50%. Symmetric signal যদি হয় তাহলে ডিউটি সাইকেল সবসময় 50% হবে. In symmetric signals the duty cycle is always 50%. You need not worry about it, right? But in asymmetric signals the duty cycle will vary from one case to another case, right? I write a problem which I have taken from the textbook. So just let me write this problem for you. The problem is the frequency of a signal is 5 megahertz. The frequency of a signal is 5 megahertz and the width of capital H is 0.05 microsecond. Find the duty cycle of H. Find the duty cycle of H. So you see that the definition of duty cycle is what? So what is the definition of duty cycle? So first of all I write it. So the solution is in this way. Duty cycle of capital H. So what is the duty cycle of capital H? So obviously the duty cycle of capital H is TH divided by capital T multiplied to 100%. So this is the definition. Now what is capital T over here? So now you see that capital T is not provided directly, but you know that T equals to 1 by frequency, and that is why you can write it 1 by 5 megahertz. 5 megahertz means 10 to the power 6 mega. So mega means 10 to the power 6. So this is the time period over here, this much seconds. Now you can write it to be 1 divided by 5 into 10 to the power minus 6. Now if you take care of this one, so 1 divided by 5 is 0.2. So you can write it to be 0.2 and then you can write it to be, okay, you remove it, you write it to be microsecond, because 10 to the power minus 6 is actually the microsecond. So therefore what is the value of TH? TH is 0.05 microsecond and this one is 0.2 microseconds, right, into this 100. I hope that you have understood this one. Now once you have got it, so if you calculate this you will get it to be 25%, because 0.05 multiplied by 4 gives you 0.2 and 4 and 100 gets cancelled to give you 25%. So you see that the duty cycle of this TH in this particular problem is 25%. So now you may get different types of problem. I have shown you one of them, ekta kore dekhiye dilam. So now you may have different problems and then you may do it in a particular way. So in your practical classes there are some practicals where the duty cycle will be provided to you. তোমাকে duty cycle টা বলে দেবে. They will provide you that design a signal, listen to me properly, design a signal such that the high value has a duty cycle of 30%. এমন ভাবে বানাও, you make a signal in such a way that the high value has a duty cycle of 30%. So duty cycle of 30% মানে কতটা টাইম সেটা তুমি জানবে. So you can easily find out that 30% is equivalent to how much time of the total signal. If the total time period, you say that the total time period is given is 20 seconds, so you understand that 30% means how much of that, and then you need to design the circuit properly by using different electronic components. Leave it, that's a different issue. Just I am trying to give you an idea of these particular topics. So I think that you have understood the importance of duty cycle, and this term is basically important whenever you are trying to discuss about the asymmetric signals, because in symmetric signals you always understand that the duty cycle is always 50%. Okay, now I will give you some idea about the about some Boolean algebra, that is the and the or operation that you have come across in your higher secondary classes. So I will show you what is an AND operation and why is the nomenclature is such that and a and namtai ba keno holo. So what is an AND operation? So let me show you that what is an AND operation. As you know that AND operation means you need to have two signals over here. So suppose you have a signal capital A and you have another signal capital B, and this is your output. So A and B are the two input signals and capital B is the output signal. Now in AND operation you should always mention that how many inputs are there, not only two but two or more inputs. It can have more, 3, 4, 5, any two or more inputs, but only one output. So inputs you may have many in number, but output you should have only one output. Two or more inputs, but output is only one. So this type of operation belongs to AND operation. Now you see that AND operation, what happens, that if in the AND operation you have both of the low values, so then the output will be low. If you have one of the low values, then also the output will be low, that is low high or high low. And if you have both of them to be high, I think that in your higher secondary classes you have read it in terms of 0 0 1 0 like that. So low is nothing but 0 and high is nothing but 1. So low gives you low, low high gives you low, high low gives you low, and only if both of them are high, so then only you get it to be high. And you believe me that this one is the most important part of a AND operation, the last one. So this is the most important part of a AND operation, that if both the signals are high, then only you will get it to be high, right? Now let me write a few observations of this AND circuit. If any input is low, then Y will be low. This is a very important observation. You see, if any input is low, this is just a recapitulation. I hope you know all this, but it's needed for our regular discussion. If any input is low, then capital Y is low. Capital Y means the output. Then capital Y is low, right? And this one, this low, as I have already said to you, that this low I should always write in capital. If any input is low, then capital Y is low. This is the first observation. What is the second observation? Capital Y will be high. Capital Y will be high. When it will be high? Will be high only when all the inputs are high. Capital Y will be high only when all the inputs are high. Very important observation. You see that when both of them is high, if it has three inputs, then when all of the three are high, then only you will get it to be high. And the number 3 that you get over here is that Y is high. This is just an alternative form of 2. 2 and 3 are basically identical. Y is high, or you may write, it's better to write in this way, Y is equals to high only if Y equals to high only if V1 equals to high and V2, not V1 over here, A, some A, only if A equals to high and B equals to high, and if you have some more, C equals to high and comma dot 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 is equals to high, right? So try to understand this. This is a very important observation. So you see that Y is high only when Y ta kokhon high hobe, only if A is high, B is high, C is high. Try to understand. Only when if A is high and B is high and C is high, এগুলো সবাই যখন হাই হবে, A is high and B is high and C is high and so on. এই যে and শব্দগুলো পাচ্ছ, you get this word and. So this and is responsible for this particular name, that why it is called an AND gate or it is called a AND operation. So why it is called AND? Because the output is high only when A is high and B is high and C is high and so on. So that is why we call it an AND operation. I hope that you have been definitely able to understand that why do we call it an AND operation. So is it clear to you that why it is called a AND operation? And you know that AND operation we basically write by using a dot. So A dot B, So this is the symbol of AND operation. If there are more, you may write C and then you may put dot 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 dot. So this is the symbol of AND operation. And the logic symbol of AND operation, because here we need the logic symbol. So you are accustomed with the logic symbol, এগুলো তোমরা জানো, so there is no difficulty. So this is an input, this is another input. If there are more inputs, you may put more over here. So this is A, B, C. যদি আরো থাকে আরো পুট করতে পারো, AND গেটের কোনো লিমিট নেই, so there are many number of inputs can be there to the AND gate. So this is what is the logic symbol and the logic expression of a AND gate circuit. And this is the logic. Point number 1 to 3 gives you the logic. Basically point 1 and 2 gives you the logic, and point 3 is responsible that why it is called an AND gate. So these ANDs are basically for the nomenclature of it. Nomenclature মানে নামকরণ. So it is due to the nomenclature. So you have got a basic ideas about it. Now I will show you about the OR gate, and then we will wind up the class for today's session. So next is the OR operation or the OR gate. OR operation. So you know that in the case of an OR operation, it is A, B and Y. If I go for it in this particular way, so then you know that if both are low, you will get low. For low and high, you will get high. For high and low, you will get high. And for high and high, you will get high. Right? So this is what is the logic expression of the OR operation. Now what are the important points to know over here? The important points to know in these OR operations are as following. So as you can find it, just like the previous one, Y will be low, Y will be low only when all the inputs are low. Only when all the inputs, only when all the inputs are low. So this is what is the first observation in the case of a OR gate. And the next observation, you find that if any of the input is high, you see that last three, if any of the inputs, if any of the inputs is high, if any of the inputs is high, comma, then capital Y will be high. If any of the inputs is high, so then this capital Y will be definitely high. You see that if any of this is high, this one is high, you get high over here. So if this one is high, you get a high over here. And if this one, if any one of this is high, either of them is high, so then you get a high over here. So here the output will be high if any one of the inputs is high. And the point 3 is just an alternative expression for a way of expressing this point number 2. So here I write Y equals to H. What is going on? Y equals to H if Y equals to H, if, now you concentrate, if capital A equals to H, or capital B equals to H, or capital C equals to H, or dot 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 equals to H. And now you see that this is the reason that why do you have the nomenclature called OR gate. Why do I call it OR gate? Because if A is high or B is high, A is high means which one? This one. If A is high, or if B is high, or if C is high, then only the output will be high. Now you see the difference between the OR gate and the AND gate. What did you have in your OR gate? In your AND gate, if A or B or C, any one of them is high, you get it to be high. But in AND gate, if A is high and B is high and C is high, then only the output is high. So So in each of these truth table or the logic expressions, you need to be careful about the high values. তুমি আগে হাই ভ্যালুগুলোতে কনসেন্ট্রেট করো যে কখন হাই আসে। You concentrate that when you get high. In OR gates, if any one of them is high, you get it to be high. But in AND gate, if both of them is high, that is A and B is high, you get it to be high. So that is how you come to the conclusions about the nomenclature of the AND gate and your OR gates. So these are a few preliminary expressions that we have been dealing with in this particular class, and I will just also show you the NOT gate in this class also, because NOT gate is another fundamental operation that you come across. The purpose of the NOT gate is just to complement the voltage. Just to complement the voltage means the NOT gate, you know, it is written as actually A complement. So A complement means suppose this is your input, and NOT gate you understand that it is single input gate. It is single input. In your OR gate also there were multiple inputs. I didn't write it, I will just show you. You have written in the AND operation two or more inputs but only one output. You just copy this entire statement. এই পুরোটাকে কপি করে নাও. You copy this entire statement and paste it in the OR operation also. Please copy and paste this one, the AND and OR. But in the NOT gate you must be careful that NOT gate is a single input gate. It is a single input. একটাই input আছে NOT gate. So you have only one input, that is A, and one output, that is Y. So if the input is 0, the output will become 1, and if the input is 1, then the output will become 0. এখন তোমাদের মনে হতেই পারে, it may appear to you that এগুলো কেন হয় বা কিভাবেই বা হয়, how does it occur? So now there are some electronic circuit arrangements. You have come across the name diodes, transistors in your higher secondary classes. You have come across the name, নামগুলো শুনেছো অন্তত। By proper combinations of diodes and transistors, if you combine them properly, then you will definitely get this type of outputs. Means if you combine them properly, then you will see that if you give a high signal, at the output you will get a low signal, and the vice versa. So that is what I am not going in the details in this particular class, because this particular class I am giving you just an introduction that what actually happens. But how actually it happens and how does it work, that will be the discussion, that will be the topics of discussion in some other class. So you see that the okay, so logic expressions I have already written over here. It is Y equals to A complement. That is the logic statement for this NOT gate, and the symbol of the NOT gate is this one. This is the symbol of the NOT gate. এই সামনে যে গোলটা দেখছো, this bubble over here, so this bubble actually means in digital electronics, this bubble actually means complement. So whenever you write this bubble actually means complement. So whatever you write, that will be complemented if you put a bubble in front of that one, right? Okay, and I didn't draw the circuit of this OR gate. The expression for OR gate is this one. The logic expression for OR gate is Y equals to A plus B plus C plus dot dot dot. Actually these are not called plus, এগুলো কিন্তু plus বলে না. In logic expressions we call it OR. So আমি যখন পড়াবো আমি বলবো A or B or C or dot 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 dot, right? These are not plus. And AND gate eও তাই. In the AND gate also these are not called multiplied. A multiplied B multiplied C. No. It is not multiplied. It is called A and B and C and dot dot dot. Okay. So এভাবে কিন্তু pronounce করতে হবে. You have to pronounce it in this way. Don't put A plus B plus C. For our regular activities I may call it A plus B plus C. But for official purposes, right? But for your practical purposes, you must call it A or B or C or D, like that. মনে রাখো, please remember this. And the logic circuit for this one was for the OR gate. এইগুলো তোমরা জানো, this is what you know. So this was your OR gate. So if this is Y, so then definitely this one is your A and this one is your B over here, right? So this is A and B. So this A and B is the input and the output is Y equals to A or B. So today in this class I have given you some overview about the different preliminary concepts of the logic circuit, that is about the symmetric asymmetric signal. I have given you some concepts about the switching times, which should be ideally 0. We have also given some ideas about the binary or the very basic, that is the digital algebra or the Boolean algebra, that is how does the counting actually occurs. I have given you some idea about the highest n bit number and how to convert the highest n bit number into its decimal equivalent, and finally we have discussed about the different Boolean operations. These are called Boolean operations after the name of the great mathematician George Boole, that there are some basic operations in Boolean algebra and these logical operations are called AND, OR and NOT. So these are the three very fundamental logic operations. এগুলো হচ্ছে তিনটা fundamental, and there are many other operations also which we will be dealing in the next classes, and you believe that all the other operations will be developed from this particular fundamental operation. In this class I have also given you an idea about the nomenclature, that why it is called an AND gate or why it is called an OR gate. The logic behind such nomenclatures has also been discussed. So for the time being we just end up the class over here. You please go through these simple ideas and before we come for the next class. Thank you.